Hey guys, so in this video we're going to show graphs of sine and cosine when they have different periods. And so a period can be defined for sine and cosine. It's going to be 2 pi over the absolute value of b, and the b you get from y equals maybe sine bx. It's the coefficient of whatever is in front of x, or it could be y equals cosine bx. So that b, you take the absolute value of that and you put it under 2 pi, and that'll give you the period length. So let's look at cosine 2x. Well, we got, thinking about it, it's cosine b of x. We can see, well, b equals 2. So that means our period's going to be 2 pi divided by absolute value of 2, which is 2. So the period is just pi. And so if the period is pi, that means the entire, for one full circle or one full wave, it's going to take pi units. So normally the period's 2 pi, and now it's just pi. So I'm going to put all the way over here just pi. And then I know that there's 4 critical points, so pi is one of them. So we can do pi divided by 4. We need to have every pi over 4 needs to be drawn in. So pi over 4, we'll have pi over 2, we'll have 3 pi over 4. And of course pi, and then we're going to do the same thing, negative. We're going to have negative pi over 4, negative pi over 2, negative 3 pi over 2, and then negative pi. And well, it's just a cosine graph, not much has changed. Nothing's changed actually with like phase shifts or amplitude changes. So we're still going to start at 1, negative 1 down here. We're going to start at the top at 0, 1. The only difference that this makes is that we're just moving in a smaller direction. Instead of moving pi over 2 units, we're just moving pi over 4. So we're going to be here. Then we're going to go all the way down to negative 1. Then we're going to start going up and up. Then it's going to be the same thing here. We're going to go down. I'm going to go back up. That'll be good enough for now. You get the point. So this is going down here. So what this phase shift did, not what the phase shift did, what the change in period size did, all it did was it squished the graph together. So it can be thought of as like a shrinking of the x-axis. So now we have this sine, y equals sine 1/2 of x. Well, we know, well, the formula what we're looking for is y equals sine bx. So b equals 1/2 in this case. Then we can plug it in right here to our formula. We're going to have 2 pi over b, which is 1/2, equals the period. Well, 2 pi over 1/2 is the same thing as, well, it's going to be 4 pi. So 4 pi is the period because we can multiply the 2 pi by 4, 2 pi by 2. So that's the period. So now, like we had here, we just made a period pi. Now we have to make it 4 pi. So 4 pi all the way over here. Remember, we have to divide it by 4, and those will be all our critical points. So it's going to be 4 pi divided by 4 is just pi. So at all the pi's, it'll be something. So pi, and then 2 pi, and then 3 pi, then 4 pi. Then we have 0. Then we've got negative pi, negative 2 pi, negative 3 pi, all the way down to negative 4 pi. And again, we see that there's no amplitude changes, there's no phase shifts, there's no up and down movement. It's just the sine function. It just has a longer period. So now we're going to start here. We're again going to follow 1, negative 1. We're going to follow the same shape. It's going to start by going up. It's going to go down. So really, as you see, not much changes with these period changes. All it does is it stretches it out across the x-axis, or it makes it a little thinner on the x-axis. The actual function looks the same. All that changed is the way we label the x-axis. I hope this was able to help. Let me know if you have any questions. Try to memorize this formula, 2 pi over the absolute value of b. You'll need that throughout your transformations. So thanks for watching. Let me know if you have any questions.